In this video, we'll get into chapter 4.3 and a little bit of 4.4, the derivative of inverse trigonometric functions and the derivative of e to the x squared. I noticed that some of you would like to know more about the process of how the formula has been reasoning, so I'll talk about the inverse trigonometric functions and the derivative of e to the x squared first. In order to derivation the formula, we need to know the relationship of inverse formula first. Here are two graphs. In the left is y equals to fx. And in the right is y equals to f inverse x. We pick a point on y equals to fx, which has x equals to a and y equals to b. In the right, we could find a point which has x equals to b and y equals to a. So that point is b comma a. And then we make the tangent of each point. Which is the derivative of them. Name the first one as m tangent. And the second one as m tangent 2. Notice that tangent lines have reciprocal slopes, so m tangent 2 equals to 1 divided by m tangent. And here from the graph, we could notice that m tangent equals to f prime x. And m tangent 2 equals to f inverse prime x. And because here m tangent x equals to a, so it's equals to f prime x, or f prime a. And m tangent 2 is equals to f inverse prime b. According to this, the inverse function of f prime b is equals to 1 divided by f prime a. So in conclusion, what we learned is when fa equals to b, f inverse b equals to a. And then we find a formula like this. So we already know the relationship of inverse function. We could begin finding the derivative of inverse trigonometric functions. We use the derivative of arcsine as an example. Arcsine. Y equals to sine x, arcsine x. Using the inverse function relationship, sine y equals to x. Then, like what we learned in implicit differentiation, we differentiate both sides, and then we get cosine y times dy dx equals to 1. So dy dx equals to 1 divided by cosine y. Then we use sine x squared plus cosine x squared equals to 1. To replace cosine y as the square root of 1 minus sine y squared. Sine y equals to x, like here. So the derivative of arcsine is one divided by the square root of 1 minus x squared. Other inverse function has the same process of reasoning, using 1 plus tangent x squared equals to secant x squared. You could try by yourself. And now let's get into the derivative of e to the x squared. The original function of derivative is limit h goes to 0. The original form of derivative is limit h goes to 0. F x plus h minus fx divided by h equals to f prime x. For e to the x squared, using in this formula is limit h goes to 0 e x plus h minus ex e to the x squared divided by h. And we simplify it, and finally we could get d dx e to the x squared is equals to itself. That's all for this video. We'll continue chapter 4.4 in the next video. Bye.